All right, if you're an engineer building with large language models, you really need to hear this. This is a bit of a cautionary tale, and honestly, it might just change how you think about the tools you're using every single day.
I mean, we've all seen the magic, right? These models can write poetry, they can debug our code, they can explain quantum physics. It really feels like you have a genius in a box. But what if I told you that, by its very design, your LLM is also an incredibly convincing, super articulate, and yeah, a brilliant liar?
Okay, so this slide gets to the absolute heart of a massive misconception. An LLM is not a database. Not even close. See, a database stores a fact as a guaranteed truth. A row in a SQL table says, Paris equals capital. It's absolute. An LLM? It does something totally different. It stores probabilities. It's basically a highly compressed, kind of fuzzy summary of the internet. It doesn't know Paris is the capital. It just knows that, statistically, the words capital of France are almost always followed by the word Paris. It's a statistical link, not a hard fact.
Now, this memory it has, it's got a technical name: parametric knowledge. Think of it like this. It's all the info the model managed to cram into its neural network during training. But it's not a library it can just go and browse. No, it's this vast, compressed memory that it's constantly trying to recall from. And just like our own memories, it can be fuzzy, it can be incomplete, and sometimes it can be flat out wrong.
The best analogy I've ever heard for how an LLM really works is to think of it as an improv actor. Seriously, this actor has read every book, every website, every article, but now they're on stage, and the rules say they are forbidden from looking at their notes. So when you ask a question it doesn't perfectly remember, what's an improv actor going to do? They improvise. They invent a plausible-sounding answer just to keep the scene going. We call this hallucination, but for us as engineers, let's just call it what it is. It's a plausible lie.
And this visual, wow, it just nails the root of the problem. The model's knowledge is like a block of ice, frozen at one specific moment in time. It knows the past, the world of its training data, perfectly. But as time marches on, this huge gap opens up between that frozen knowledge and the live, constantly changing world of today. The model isn't learning in real time. It's just guessing about the present based on what it knew way back in the past.
Let's break that down a little bit more. So, imagine a model with a knowledge cutoff of, say, January 2023. As far as that model is concerned, the years 2024 and 2025, they literally just never happened. Poof! Every new company that was founded, every product that launched, every major world event, it's all happening in a world the model has absolutely no access to. And that gap between its knowledge and reality, it just gets wider and wider every single day. And here's the truly dangerous part. The model will never say, "I'm sorry, my knowledge is out of date." Nope. It's going to answer with the exact same confidence and articulation as it would if you asked it about a historical fact. It puts on this incredible facade of being all-knowing, while its information is becoming more and more obsolete by the second.
Okay, so this isn't just some abstract theory. Let's walk through a very concrete, very real-world kind of failure. We'll call it the Denver Lounge incident. So here's the anatomy of the disaster, step by step. First, a customer asks a simple, time-sensitive question. Second, the model, with zero access to live information, consults its frozen, completely outdated 2023 memory. Third, it delivers the answer that was most statistically probable based on that old data, an answer which is now critically totally false. And finally, the customer pays the price for that lie in the real world.
This comic just lays it all out. It's January 14th, 2025. You've got a traveler at the airport who asks the airline's AI, "Hey, is the Denver Lounge open right now?" The AI checks its 2023 parametric knowledge and super cheerfully responds, "Yes, the Skystream Denver Lounge is open until 10 p.m. today." So the traveler walks all the way across the terminal, only to find a locked door. The lounge is actually closed for emergency plumbing repairs, a simple temporary fact the model could never have known. The result? They missed their flight.
So why? Why did it get this so catastrophically wrong? Well, because in 99.9% of its training data, all those travel blogs, reviews, and official hours from before 2023, the lounge was open. The model didn't malfunction. It did exactly what it was designed to do. It predicted the most statistically probable sequence of words. But that is not, and never will be, the same thing as telling the truth.
And that right there brings us to a pretty hard reality. As engineers building systems that people actually rely on, we have to recognize this fundamental flaw, and we have to change our entire approach.
Look, if you remember just one single thing from this, make it this sentence.
In enterprise engineering, statistical probability is not a substitute for truth. We cannot build reliable, trustworthy applications on a foundation of probably or usually. We need facts, period.
Now, the obvious solution might seem to be, well, let's just retrain the model every day. But that is wildly impractical. Not to mention, it costs millions of dollars. It's kind of like trying to fix a cracked foundation by constantly repainting the walls. The problem isn't the paint, it's the architecture. We need a new blueprint.
So we've established our LLM is this brilliant improv actor, right? But it's being forced to rely only on a faulty, totally outdated memory. This leads us to the single most important architectural question we can possibly ask. What if, right before it has to speak, we could give that brilliant actor an open book of up-to-the-minute facts to read from? What would happen then?